first speaker is Susan Forney from Hurricane Electric. She's going to talk about Peering Economics 101. Susan, over to you.
Beautiful. So I squared that slide.
Yes, while they're getting this up, I'm Susan Forney. I'm a network engineer at Hurricane Electric. I'm also a member of the board of directors. And I am the same Susan Forney who for a very long time worked for a small software company in Redmond, of which you may have heard. So I'm here today to talk to you about Peering Economics 101. And next, is there this thing here? Okay, this will work. All right. All right, so I plan to answer the next 5 questions. Why is peering never free? When is peering worth the investment? What type of peering should I do? Why do I need a peering strategy? And why should I be a good neighbor? So we'll start out with the first one. Why is peering never free? No, it's not going forward. There. Okay, so why peering is never free? First, peering is a connection between 2 network devices, and as many of the vendors in the room can tell you, these devices are not free. People are needed to configure and manage network devices, and obviously, people are not free. All of you in this room get paid. The network devices need electric power and a space to occupy, and as you've noticed when you've tried to put them places, that's not free either. So, peering has a cost, but as with anything that has a cost, it also has a value. And so to determine its value to you, you're going to need to know first how much your peering port costs. So besides equipment, don't forget optics, its rack space, power, and support costs. All of these factor into the investment that you are making in putting that port into an exchange. Then how much does a cross-connect cost at the data center that hosts you in the exchange? Don't forget the setup fees for that. And while it's true that each of your transit providers also consumes a port and a cross-connect, it's just a good exercise to keep track of these kind of costs. If for no other reason, when that guy from accounting comes in and wants to know what your budget is for the next year, you have some good answers for him. So I put this chart together to get an idea of what these costs use, and I use these in my presentation, so I'm going to go over them a little bit carefully. The first one is, like my ISP, that's my transit provider. So the cost there. Then my IX would be the cost for, your basic IX. And I used round figures to make the math a little bit easier. So, like for an ISP, an average port on a device is going to cost you about 200 euros. Setup fee for a cross-connect maybe around 500 euros. And then setup fee for the service, maybe 250 euros. Based on my experience, those are kind of average costs. So, of course, if you buy, and we're assuming a 10 gig port here, if you buy transit from an ISP, they're going to want a commit, and standard for a commit for a 10 gig is around 2 gigs, so 2,000 megabits. Then the commit price, we're going to price the bandwidth at euro per megabit, so that's going to be 2K euros. And then if you burst above that, we'll just call it another euro per megabit. And then price per port doesn't come into effect here because it's transit. And then a cross-connect fee of, say, 250 euros a month. Now, then you look over at the exchange. And at first, this looks pretty simple. It's going to be the same for the device port, doesn't cost any more. Same setup fee for a cross-connect. But you usually don't have the setup fee for the service is usually a little bit more on an IX. I put 500 euros because it looked like that was more or less normal. Then we don't have a commit level on an inner exchange. We don't have a commit price. We don't have price per megabit permit. That's all free, right? And then price per port, about 500 euros on average for your 10 gig ports in a lot of exchanges. And then the cross-connect costs are the same. So, right there, it's looking pretty good for the IX. So, let's keep going. So, while it's true that each of your transit providers is consuming that port, looks like I've... Anyway, let's determine if your peering port is a good investment. You also need to think about how much traffic you could move to this port. So, to determine how much traffic you could move to the port, you should consider who your potential peering partners will be on the exchange. So exchange is where that you can read content providers or clouds like Amazon or Google. Those are good places to be. They can be very advantageous. You're using those services anyway, and it's a good way to offload that kind of traffic from your transit provider. Don't forget to peer with caching networks like Akamai and Fastly and Limelight. That's where a lot of your traffic is going in the first place, and so you can save yourself a lot of bandwidth if you're peering with them. And then finally, NetFlow or SFlow can give you a lot of information about your highest traffic sources and destinations. And to give an example of how this might work, I helped some people I knew at a university one time try to figure out whether or not they should go to an internet exchange. And so I asked them, well, how much traffic, do you send to, what destination? They had no idea. And I said, what about your SFlow? And they didn't have that set up. So fortunately, they had a vendor who wanted to do a trial, so we set it up. And in about a couple of weeks, we had a collector set up, and we started to get some decent data. This is a university, and so we thought, oh, there's going to be a ton of traffic to, research networks and, academia and, that. So we'll find out where this stuff is going. No, because the university also supplied traffic, supplied internet to all of the dorms. 75% of their traffic went to streaming services like Netflix and Hulu. So, that if they had not known that, they wouldn't realize that for their biggest bang for the buck on that exchange would be peering with Netflix or one of those streaming providers to save them a ton of money. So that's the reason why you should take a look at where your traffic is going if you don't already know, to make sure that you can make some strategic decisions. So once you have all this information, you can see if getting the port on the exchange is actually going to make good business sense for you. So I did a quick chart here, based on the cost. Remember, before our ISP cost is basically a euro meg, and our cost for the exchange port is 500 euros a month, and then we added in that $250 or 250 euros a month for the cross connect, and so that puts the exchange port at 750 euros, right? So when you look at the orange line, which is the exchange port, and the blue line, which is the ISP, if you just look at the straight cost, it looks, pretty elementary. The IX port is obviously cheaper, right? Except you need to look at a little bit more than that. So what actually is happening here is, in this graph here, I've shown you what it looks like if I've moved my traffic 50% on ISP, which is the orange line, and 50% on the IX, which is the gray line. And then this blue line here shows you the actual cost, the average of the two of them. And still, the IX is looking pretty good. But it doesn't take into account your commit rate. So this is what really happens. Your actual cost is still the blue line, and your ISP is still the orange line, and your IX is still the 50% line. But then the cost to where you break even doesn't actually happen until 4 gigs if half of your traffic is on the internet exchange and half of your traffic is on the ISP, because you have to meet that 2 gig commit before you ever start making money off of the exchange, because otherwise you're paying for that 2 gigs whether or not you use it. So let's say you've got 3 gigs of traffic and you move 2 gigs to the exchange. Well, okay, you only got 1 gig on your transit provider, but you're still paying for 2. So you have to factor that in when you think of those costs, so that you don't leave, potential money on the table. Now it's not a complete waste of time to be on an exchange, because if you move to the exchange, then when you renegotiate your bill with the transit provider, that could give you an idea that you might need to buy a little bit less, or maybe have fewer providers, whatever it would take to balance the costs. But you really have to think about these things before you just say, oh, my peering port is free, because it actually costs you a lot of money. So also, don't forget to factor in operations costs, because you can save by streamlining or automating them. One of the things you could do that would make it a little bit cheaper for you is to set ports up on the exchange. Obviously, you want to peer with as many people as possible. If you are configuring each one of those ports individually, you're wasting a lot of time and money, because people cost money. So set up a couple of peer groups for your neighbors that, categorize them into a couple of basic groups. Most everybody will fit into these sizes. And then then all you're going to need to know from a neighbor to turn these things up on the exchange is their AS number, their IP address, their AS set, and what their suggested max prefix limits are. And then you can very quickly fit them into one of these categories and turn your peers up in minutes. Saves you money. Then consider the support priority of your peers. If you're waking your engineers up in the middle of the night to fix peers on the exchange, and it's not something like in the university's case, Netflix, where that would be real money to you, you're probably wasting money, because and the reality is that if a peer goes down the exchange, it can probably be fixed the next day. You can contact them later. It's not the end of the world if one guy on an exchange is not peering with you anymore. So you might not want to wake your engineers up in the middle of the night, because that actually costs you money. It seems like it's free, but a guy who didn't get any sleep the night before, it's probably going to cost you the next day. So you want to make sure that you are making operations calls that benefit or merit the port. And then monitor your port connections on your IX and increase it before you get into trouble. This is something I see happen all the time. The port's free, right? So nobody thinks about the capacity, but you really have to manage that just like you would with your transit connections, and make sure that you're not oversubscribing that port, because that's going to drop packets on the floor just like anything else. And then you can do things like use communities to make your peering smarter, so that you are tagging your traffic and you have a better idea about and more control over what you're doing, and it saves you time and money. So also about thinking about what the investment is, your investment is not all about money. Peering can provide real tangible benefits in terms of reduced latency and improved throughput. So if you are a subscriber of a cloud service, for example, and you can peer directly with that cloud provider and cut down the latency for your customers, or let's say your office uses Google Office, and you can peer with Google on an exchange, and all of your Office applications now suddenly have a direct connection instead of going over the internet, you're going to provide a better user experience for the people in your office. And that's worth something. Sometimes that's worth paying more for. So, in some cases, spending a little more money on a peering port that you wouldn't automatically have to spend pays you off in terms of higher customer satisfaction or better throughput. Also, you gain more diversity at your edge when you peer on an exchange. This is going to help you improve traffic flow, decrease latency like we just talked about. And you also can help your routers rebuild their tables more quickly when a link goes down, because the more places you peer with, the more ASs you have your traffic spread over, the less exposed you are when one of those goes down. So you have fewer routes on a single, that are the best route on a single AS, and then your routing tables converge faster. So it's to your advantage. It improves the scale of your network and prepares you for future growth. Again, mostly because the more ASs you peer with makes you, a little bit more stable and more scalable. And your internal and external customers are likely to be happier because you're getting better performance. So, what type of peering should you do? Well, the easiest option at most public exchanges is to peer with the IX's route server. If you are crunched for time, you just don't really know what you want to do, and you want to get the advantage of peering with something on the exchange and get set up right away, peering with the route server is going to give you a whole all of the routes of anybody else who's peering with it, and that can be great. In this example, your router would only have peering sessions with the route server, cuts down on the amount of things you have to set up. It's a quick way to get access to the networks on the exchange that peer with it. And if you peer individually, you can still peer with the route server as a backup, but you might want to prefer the directly connected routes over the route server. The disadvantage of peering with a route server is that you have less control over the routes that you get. And you may not get all of the available routes, because when people peer with route servers, they don't always advertise all of the routes they have to the server. Many networks only advertise a subset. And some people choose not to peer with the route server at all, and the other bad news is that some internet exchanges don't have route servers. Oops, got one too. It went too, I don't know, it really went, there we go. That was a lot for just one click. So, the other type of peering you can do takes place across a private direct connection, and I just mentioned this because it's another way to peer. Some in cases where between a couple of large networks, sometimes they don't go across the peering exchange. Sometimes they peer directly with a cross connect inside of the data center, and it's still a peering session, but it bypasses the exchange server, or the exchange switch, which some IXs like if you're going to pass a lot of traffic off there, and it allows you to have a direct connection with another network. And then you negotiate who pays for the cross connects, and usually people take turns and take care of it that way. So the other type of peering, of course, you could do is to peer directly with the networks on the exchange, and it's the most common and convenient way to set these things up. You have more routing options when you peer individually than you do when you peer with the route server. And once the port, your exchange port's in place, you can turn up as many directly connected peering or direct peering sessions as you want. Makes it very fast. And I also mentioned that peering across the exchange fabric can be free or settle. I've seen people go into settled or paid arrangements across peering exchange. It's not very common, but does happen. So now that we've determined what kind of peering you can do, we need to talk about why you need a peering strategy. And really, you need a peering strategy to get the most value out of your exchange port. So what you need to consider are what networks are going to benefit you the most from peering, what exchanges should you join, and how will you route the prefixes that you receive in your network. And so this is important because, as we have demonstrated, these peering ports cost money. And so you want to be a little bit strategic about where you decide to, put your routers and your switches and where you want to peer. And then you want to also make sure that you identify and prioritize the peers that are the most important for you, because if you get into a situation where you have not enough bandwidth on your port for in an exchange, or you get it to the point where, let's say, you start to come up against the limit of your port and it takes a while to upgrade, then you might want to know whose routes you might want to turn down and not listen to, because you want to make sure that you get the best traffic across that port and you're not listening to just everything. And then you need to figure out how you're going to route the prefixes in your network. So if you need to determine if a peer makes sense for you, first, again, do you send a lot of traffic to this peer over the transit connection? Because if you do, then peering with them across the exchange obviously is going to save you money. And can you get lower latency? Are you going to improve performance? And do you have excess bandwidth on the IX switch? So to give you an idea why a peering strategy is important, I've got this little this little story that I like to tell about what happens when you don't think about where you're peering and where your traffic is going to go. And in this case, I have a fictional company that is green, and they have a satellite office in another country where they have a router that connects to the internet to give them better performance because they don't want to have to go back to the home country. So they're over here and they've got a connection to the internet. Everything's great. Now it turns out that this satellite office does a lot of communication with this network over here in the same country, and you can see they've got a couple of downstreams, but this works out really well for the satellite office. They have good connectivity back to the home office, and they've got good connectivity to the places where they do the most business. So that's going great. Now, this company, the home office, decides, oh, there's this internet exchange over here, and we're going to connect to it, and they just set up a peering session with our friends over here at this network that their satellite office does a lot of business with. But they weren't thinking about that. So then what happens is they don't prioritize the routes properly, and now their satellite office is going back to the home office through the IX and then back down to this network where they do a lot of business and adding a lot of latency to their network path instead of improving it, which is the whole point of being on an internet exchange, is to improve things, right? You get better latency, better throughput. And instead, because they're not paying attention to what's being advertised, it's actually getting worse. So this is the reason why a strategy is important and why you need to think really carefully about who you're peering with and where the traffic is going so that you make things better. So as we have seen, peering can improve your routing and reduce latency or not. If you peer at more than one location, you need to consider a routing architecture that allows prefixes to be allowed strategically to keep traffic local, so we don't get into that situation where we're moving traffic across countries where we don't have to. And then some peers can benefit your network more than others, and figuring that out is going to give you a bigger return on your investment. So now that we've talked about all of that, we need to talk about why you should be a good neighbor when you are on an internet exchange. This is just good business. Peering works when it is a good experience for both parties. So clean up your route advertisements. You should not be leaking your private IP space to your peers, or routes that don't originate from a public AS. When you do this, the guys on the other side see this, and it does not inspire a lot of confidence. So you want to make sure that you've controlled your advertisements and that you are advertising things that the routes that you want to. Be easy to contact by keeping your contact information up to date in PeeringDB or in RIPE. This is important because in the event of an emergency, people want to be able to contact you, and they want you to be able to tell you about problems. Like if you've got a phishing problem, or somebody is sending spam, then you need to be easy to contact, or somebody's hijacking a route. You need to be easy to contact. So make sure that you are following manners, and that you are keeping PeeringDB up to date, and that your RIPE contact is up to date. Also, keep your IRR records up to date. And this is important because today there are many large ISPs that will not accept your routes if you do not have accurate IRR records. So if you don't have a valid origin, or let's say you're in a case where you've got some downstreams and you don't have a valid IRR path recorded in your IRR and your records in your AS sets, then that route will be dropped at the ISP. And a good example of this is, like, for Hurricane Electric, we accept letters of authorization from a customer to allow them to advertise downstream routes. The problem is if that customer doesn't go back and collect the IRR records, then when I advertise to those routes to a ISP like, say, NTT or Telia, which does not allow these routes, they will drop that prefix. And you don't. It's not like the route goes a different way. They just drop the prefix, and so that traffic just falls in a hole. So if that destination is in NTT or Telia, the traffic never comes back, because they're not accepting that. They're not accepting that your advertisement the way back from you, because it doesn't have a valid IR record. And you should a good if you're peering if you're filtering properly on your internet exchange, you shouldn't be accepting those routes either. So it's important to keep your IR records up to date. And then while the other networks you are peering with are probably fine people, you really should not trust anyone. You really don't know what's on an internet exchange. And in some cases, maybe you do know the network really well, but you're going to peer with people that you don't have personal relationships, and maybe you don't know really well. So you shouldn't trust them. The first thing you should do is set maximum prefix limits for your neighbors. And the story I like to tell about that is, once upon a time when I worked in Seattle, I was in a telco hotel, and I came in early in the morning, and crawling out of the elevator was this other guy that I knew that ran an ISP, and he looked like he was half dead. And I said, "What happened?" He goes, "Oh, one of my peers last night, they re-advertised the internet to me." And I looked at him, I said, "Didn't you have max prefix limits set?" He said, "I do now." So don't let this happen to you. And honestly, you think that this is an isolated case, but just last week I was talking to a peer who thought that we had, de-peered him, and his port had just shut down because it accidentally advertised too many routes because someone else was advertising the internet to him, and he was trying to advertise it to us. And so, we had the conversation about max prefix limits there. Happens all the time. So please don't set peers up without max prefix limits. Just easier for you. Filter the routes to accept only routes from peers that are valid from the peers AS, and deny private IP space and bogons. And this is actually easier than you think it is. Building filters does not have to be hard. You can script it yourself, or you can use a tool like BGP-Q3. Here's an example that I give using BGP-Q3 to generate a prefix list for Juniper router. So all I did is just type in BGP-Q3 -J for Juniper, -6 for IPv6, -L to give it this minute prefix name, and then the AS is the argument that I want it to generate the list from. That's all you have to type. You hit enter, the entire configuration is built for you. And it will do it for a number of different router manufacturers. And if it doesn't do it exactly right, you can audit your script and put sequence numbers in and do whatever you need to do to make it work for yours. But you can generate these daily or weekly. Weekly is probably the least amount of time you want to do it for. But you can and then put these in place automatically and script this so that you can put a filter in front of every single one of your peers. It's just a really good idea to do this. So lastly, be responsive when you're notified of an issue. Nobody likes a peer who ignores them, especially if they're experiencing DDoS or phishing attacks or other types of behavior that is undesirable. No one can take advantage of you without your permission, so control your advertisements. If you are controlling the routes you advertise, it's really hard for someone to do something that you don't want them to do. And not all networks are going to want to peer with you. And this usually has a lot more to do with their peering policies and strategies and less to do with you. But on the other hand, if you want to peer with somebody, if you don't ask, you don't get. So don't be shy about asking people to peer, and don't be shy about asking, periodically if you really want to peer with someone and they said no in the past, because sometimes peering policies change. Like for instance, somebody may not peer with you because their peering port's already full. Then they upgrade their port, and you ask them later, they say yes. So never hurts to ask. So that's all I had for you today. Does anybody have any questions?